So very good morning, students. Welcome to IIT NEET Foundation or Focus C program by Krishnaveni Talent Schools and the Mastermind Schools. So once again, I welcome all the participant branches for today's session. As you can see on the screen, and you are well aware, my subject is physics. We are in class 8. Our ongoing chapter, that is 6th chapter, electric current. And today we are in the session number 5. So far we completed 4 sessions in understanding the electric current, which is the syllabus for our test 6. Test 6 syllabus is electric current only, which is on 30th December. So we are going to have 2 more sessions. After this, 1 more session we have to complete the chapter in details, and you can appear for exam on total entire chapter of electric current. That is overall total 6 sessions. Today is the 5th session. 1 more session we'll have on Friday, right? So all the syllabus covered in the 6 sessions will be appeared in the test 6, which is on 30th December, right? So in meantime, you prepare what the syllabus covered from the material regularly whenever you will get the time, so that you can appear for exam and get the very good marks, right? So we'll continue where we stopped the last class. Ramnagar, good morning. So these are the topics what we already covered, right? Also we covered about resistivity also, apart from this. So you can see here, we learn about what is the prehistory of electricity. So what is electric current and its units, electric potential, potential difference, and Ohm's law, very important. After Ohm's law, we discuss about the resistance. From the resistance, we got one more important word, resistivity. Right? Resistivity, on what factors resistance depends. Based on that, we derived R is proportional to L, R is proportional to 1 by A. From that, we got R is proportional to L by A. From this, R is equal to rho L by A is the formula. Where rho is called resistivity, is given by RA by L. That is ohm meters or ohm centimeter is the unit for the rho, which is resistivity or specific resistance. Right? Up to here we learned, and also we introduced some of the effects of electricity also. So next 2 classes, we are going to discuss deep into the effects of electricity. So what happens when electric current passes through various conductors, like solid conductors, liquid conductors. That effects we'll discuss. Already we introduced in the last class, like heating effects of electric current, lighting effects of electric current, magnetic effects of electric current, right? All these we have seen chemical effects of electric current. So today we are going to learn in deep. So this already we have seen electric current. What is electric current? So unit of electric current is ampere. What is ampere definition? Then we learn about what is the electric potential, potential difference, work by charge, which is measured in volt, measured by voltmeter. Then Ohm's law, relationship between electric current and potential difference. From that we got the formula V is equal to IR, the famous formula. And we have seen the magic triangle also. So this is the Ohm's law. How to observe, how to verify the Ohm's law is the setup. All the arrangement, diagram, we can call it as circuit diagram. Right? Then what is resistance? So resistance is the property of slow down the flow of electron. I told already, it's like a speed breaker. How speed breakers are arranged to control the speed of the vehicle. Even to control the flow of electrons also, we use the resistors in circuit. Very important role. And this property of resistance depends on few factors. That is length, area, temperature, and nature of material. Already we discussed about that. From that we got the formula what I explained more first. See here we got it. Right? Now we are coming to details about the effects of electricity. That is synopsis 3 we are entering. Entering into the synopsis 3, where we discuss about chemical effect of electric current. What is the meaning? What happens? So what happens when current passes through liquid chemical, which are liquid chemicals are also called electrolytes. Electrolyte. So what happens when you pass, suppose when you pass electric current through water, water does not allow the current, it is a insulator. But when you add some salt, pinch of salt into water and mix it, then you allow the current, it will pass. So like that, when you pass the current through any liquid chemical, the chemical decomposes into components, decomposes into ions. Suppose if you take CuSO4, when you are passing current through CuSO4, the Cu becomes positive and SO4 becomes negative. So the positive will attract towards the negative terminal, negative will attract towards the positive terminal, the deposits. Like that, what is happening here? Decomposing. That is known as electrolysis process. Electrolysis. Suppose when you are adding the salt to water, Na plus, Cl minus. Right. Like that, whenever you are passing current through a liquid chemical, the chemicals are decomposed into ions. Such effect of current is called chemical effect of electric current. So, day-to-day life, there are a lot of uses, applications, so you can see in that. Just you can see from to see here introduction to chemical effect of electric current. Right? So, electrical conductivity is the measure of the ability of substance to conduct the electric current. So far, we have used our tester or test the electrical conductivity of solids. Let us now perform the following activity to find whether all liquids conduct electricity or not. Liquids are not such good conductors as metals. So, in this situation, you may have found that the bulb does not glow. Although the high conducting, this is because of the current through the circuit is too weak, so that the filament of the bulb does not get heated sufficiently and tube light not glow. It is a liquid. So liquid conductors, liquids also some conductors are there, but they are not so strong as solids. Okay. See, good conductors, G is there here, good conductors of electricity. Materials which have electric current to pass through them are called good conductors of electricity. All metals are good conductors of electricity. Human body is a good conductor of electricity. Right. Now, what about the chemical effect? That we can see continuation. So, bad conductors of electricity. Good conductors are which conduct electricity. Materials which do not allow electricity to pass through them are called bad conductors, like plastic, wood, etc. Paper. All liquids are bad conductors of electricity, except mercury. Mercury is a liquid metal, which is liquid metal. Pure water is a bad conductor of electricity, but impure water conducts the electricity. Impure means you can adding something to that, like salt, adding salt. All gases are bad conductors of electricity. Right? Then, now come to the chemical effect. So what we have seen? What are the good conductors? What are the bad conductors? Now we'll see what is the effect of electric current, that is chemical effect. But before that, I will show you one video on the effects of electricity. First you see that, then I'll give the complete explanation for you on the various types of or various effects of electric current, right?
Electric circuit. The closed conducting path in which the electric current flows is called an electric circuit. An electric circuit constitutes of a source of electric current, cells, etc., a conducting wire, an electrical appliance, bulbs, etc., a switch or key. When the switch is closed, the circuit is said to be closed circuit. In this condition, current flows and appliance works. Example, the bulb glows. However, the circuit is said to be open circuit when switch is open and there is no flow of current. Source of electric current. A device that produces an electric current is called a source of electric current. Example, cells, batteries, etc. Battery.
Just recall of the
When two or
chapter.
more cells are used to draw an electric current, the combination of cells is called battery. In battery, positive terminal of one cell is connected to the negative terminal of the next cell. Many devices such as torches, transistors, toys, TV remote controls use batteries. Bulb. It produces light and is represented by coiled wire inside the circle as shown. Connecting wire. The connecting wire is represented by a straight line. It is usually made of copper and provided with insulation. Plug key. A plug key is an electric switch. It is shown in both on and off positions in figure. Cell. A thin long line represent the plus terminal and thick short line the negative terminal as shown. Battery. A combination of two or more cells is called battery. Its symbol is also a combination of cells symbol as shown. Fuse. It is safety device in electric circuits. The components such as cells, bulbs, wires, etc. are called elements of an electrical circuit. The various components of the circuit are represented by standard circuit symbols. It is much easier to draw a circuit diagram using symbols. Therefore, we generally represent an electric circuit by its circuit diagram as shown. Symbols of some common components are shown. Heating effect of current. When an electric bulb glows continuously for a long time, it becomes very hot as some part of the electrical energy is converted into heat energy. This is known as heating effect of current. The heating element in many electrical appliances like electric rod, electric oven, electric toaster, etc. is made of nichrome alloy.
Nichrome.
Take a 10 centimeter long piece of nichrome wire. Tie it between the nails. Now touch the wire and switch on the current in the circuit by moving the switch to on position. Touch the wire again. Do not hold the wire for a long time and switch off the current. Touch the wire again. After a few minutes, we will observe that the wire becomes hot when an electric current passes through it. This is the heating effect of the electric current. Safety devices. Mini circuit breaker used to protect circuit from strong current. Strong current often leads to overheating of wires, which can result in the breakout of fire. Fuse also used for protection of circuit, which consists of a thin wire of low melting point. In 1820, the Danish physicist Hans Christian Ørsted discovered that flowing current in a conductor generates a magnetic field. Ørsted demonstrated this by connecting the two ends of wire to a cell through a switch. Then he placed magnetic compass near the wire. Now when he allowed the current to pass through the wire by closing the switch, he observed deflection in magnetic needle. He also noticed that it requires its original position when the flow of current is stopped. Take a discarded matchbox and wind an electric wire a few times around the cardboard. Place a small compass needle inside it and connect the free ends of the wire to an electric cell through a switch. Note the direction of the compass needle. Bring a bar magnet near the compass needle. We will observe that the needle gets deflected. At the same time, move the switch to the on position. We will again observe that the needle gets deflected again. Now move the switch back to the off position. We will observe that the needle comes back to its original position. So, we conclude that when electric current passes through a wire, it behaves like a magnet. Take the tray from inside a discarded matchbox. Wrap an electric wire a few times around the tray. Place a small compass needle inside it. Now, connect one free end of the wire to the terminal of a battery. Leave the other end free. Take another piece of wire and connect it to the other terminal of the battery. Insert free end of wires into half cut of potato and observe. You will observe that a compass needle gets deflected and also find that it was always the wire connected to the positive terminal which has greenish blue spot around it. They felt that the discovery was very useful because it could be used for identifying the positive terminal of a cell or a battery concealed in a box. Electromagnets. Current-carrying wire or a coil of wire behaves like a magnet. If a permanent magnet is brought near the coil, one end of the coil gets attracted and the other end gets repelled. This shows the opposite polarity of the coil. If a piece of soft iron is kept inside this current-carrying coil, the iron piece gets magnetized temporarily. Such magnets are called electromagnets.
Electric bell. An electric bell is one of the most commonly used applications of electromagnets. It works on the magnetic effect of current. It produces a repetitive buzzing or ringing sound when an electric current is passed through it. Electric bells have been widely used in telephones, fire, and burglar alarms, at railroad crossings, as doorbells, school bells, and alarms in industrial plants, but they're now being replaced with electronic sounders. An electronic bell consists of an electromagnet, springy iron strip, a hammer, a gong, and a switch. An electric bell works on the principle of electromagnetism. It is a simple device which has a U-shaped solenoid, one end of which is connected to a spring of the switch, and the other end is connected to a soft iron armature. Basically, all the components such as the switch, electromagnet, hammer, soft iron armature, and spring are connected in a circuit to make an electric bell. When electric current is allowed to pass through the circuit, the iron core of the solenoid gets magnetized and pulls the soft iron armature, which causes the iron hammer to strike the gong. When the armature moves toward the poles of the solenoid, the circuit breaks and the solenoid loses its magnetism. This forces the armature and the hammer to return back to their original position.
Okay, these are the various effects of electric current, which we are going to learn physically, right? So first we are starting with the chemical effect. So chemical effect is the process where we can have the process. So electrolyte the liquid chemical is called electrolyte. I told you, electrolyte is nothing but liquid chemical. Just a minute. Right. So chemical effect of electric current. So when chemical changes occurs in a substance due to passing of electric current is known as chemical effect of electric current. Means when you are passing electric current through a chemical, if any chemical changes takes place, whether it may be permanent change or temporary change, no matter, that is physical or chemical, but any changes takes place, that is called chemical effect of electric current. Electrolysis and electroplating. See, electrolysis, electroplating are the two phenomena which are based on the chemical effect of electricity. So electrolysis already I told, whenever you are passing current through a salted water, so their decomposition takes place. What about electroplating? Electroplating, if you remember, 1 gram gold, right? 1 gram gold you might have heard. That is called rolled gold ornaments. So 1 gram gold is nothing but gold coating is done over some other material. Whenever one metal is covered by other material, by passing electric current, that process is called electroplating. So 1 gram gold will become stainless steel. So when you see your utensils in the kitchen, the plate you are eating, that is called stainless steel. Over steel we are coating with the chromium. Whenever chromium coating is given over the steel, we can call it as stainless steel. That is also done by the passing electric current. That is called electroplating. Coating one metal over the other by passing current. Right? So electrolyte. So what is electrolyte? I already told. That is a liquid which allows passage of electric current through them and dissociate into ions is called electrolyte. So dissociate, decomposes into positive ion and negative ion, electrodes and cathode and anode. Right. So what is electrodes? Metal plates partly immersed in the electrolyte to pass current through them are called electrolytes. These two. Here see we have. These are called electrolytes. One is cathode, other is anode. They are placed in a chemical. When they are connected to a battery. When current passes, you can see the chemical decomposes and deposit near the cathode and anode. So negative terminal is called cathode and positive terminal is called anode. In solid conductors, conduction is due to motion of free electrons, and electrolyte conduction is due to ions. So in solids, the conduction is due to motion of electrons, but here ions. Ions will move from one place to another place, make the electricity to conduct. Right? So positive ions are called cations, negative ions are called anions. Okay? So electrolysis of sodium. When electricity is passed through a solution of NaCl, common salt, right? As an electrolyte, the following products are formed at the electrodes. So in the solution, there are Na plus and Cl minus, H plus and OH minus. What are also there? Na? Ions. H plus is discharged at the cathode, whereas Cl minus is discharged at anode. Salted water. Salt is there, water is there. In both, there is a cathode and anode. So they are decomposed when you are passing current. As decomposed, they are connected in the two electrodes, cathode and anode. Such phenomena is called chemical effect of electric current, which are commonly seen in the electrolysis process, electrolysis, or simply electrolysis. Similarly, electroplating also told. What is electroplating? Coating one metal over the other. Coating one metal over the other. So already there see some applications are given. Electrolysis has number of applications. For example, it is used to extraction of metals, purification of metals. The most general electrolysis is electroplating. So when you are industries, big industries, when they are extracting the metals from their ore, which is called metallurgy, that during that they'll use the high electricity to decompose the chemicals into two components, two ions. So this is very much applicable in our day-to-day life in the industries for the purification and extraction of metals. Not only extraction, they can purify the metal also. Pure form of metal can be obtained. It may be gold or iron or silver, aluminum, anything. Okay, then electroplating. This is also one of the important chemical effect only. I told when you want to coat one metal over the other, subsequently tap disease. Tap is coated with the chromium or gold, silver over the iron. Right. So electroplating is a process of coating thin layer of metal such as gold, silver, copper, chromium, tin or nickel on the inferior metal by means of an electric current. By passing current, what we do? We are coating one metal over the other. One is the costly metal, other one is the inferior, means less costly metal. Over less costly metal, we are, for example, over silver, you are coating with the gold. 1 gram gold, that is nothing but. So that is called, that method is called electroplating. So there are innumerable applications in electrocoating. So many places you can see you are coating of these metals. You can quote kitchen utensils, all stainless steels are nothing but coating of chromium over steel. Right? We cannot directly eat steel. Steel is the rough form of the iron. So what we'll do, we have to coat with the chromium and make it as a stainless steel. Right? So when you see the users here, electroplating is the most useful process in the industry for coating the metal objects. Some of them are given below. Chromium is shiny metal that does not corrode easily and it is resistant scramble. Chromium is an expensive metal, so whole object could not made from it. Therefore, it is deposited on the objects of cheaper metals like iron to make part of cars and bicycles. Rims, what is there? Rims and everything made up of stainless steel only, where over iron we will coat the chromium. We cannot coat entirely the chromium because costly. Even steel materials also, taps also. Tap also you can find steel taps. They are not completely chromium. Only over the steel we are coating with the chromium for protection. They won't undergo erosion quickly. So second one, gold or silver is electroplated on less expensive material. Therefore, jewelries are as much as expensive as made by the gold or silver. That is also comes under plating only. Coating of one metal over the other called as electroplating, which is one of the important application of chemical effects of electric current. What is this? Chemical effects, right? So we'll move forward to know more about this. Right. So tin cans used for the carrying the food are made up of iron and electroplated with the tin. Tin prevents the iron to come into the contact with the food. So the food does not spoil. Tin plated can. Okay. Then zinc coated iron is used to make the bridges, buildings, automobiles. So the coating of zinc prevented the iron from the rusting. To avoid rusting because oxidation. Because oxidation may rust. So to avoid that rusting only you are coating with the tin. Right. So next one is magnetic effects of electric current. So far we discussed about the chemical effects. So whenever electric current passes through a liquid chemical called electrolyte, that decomposes into ions and deposited in respective cathode and anode. And they gives out anion and cation. And there also method is also used for the coating of one metal over the other. One metal over the other called electroplating. What? Electroplating. Right. Now, as you have seen in the video also, magnetic effects. So these properties observed in the year 1820 by Henry Oersted. What he observed is every current carrying conductor produces magnetic field. As long as you are passing current through a conducting material, conductors only, all the metals, they produce the magnetic field around it. He tested by placing the compass near the current carrying conductor. Right. And by that he found that is the effect of electric current over the magnetic field. And such effect is called magnetic effect of electric current. Right. So then you can make the electric pen also, glowing pen, by using the cell. So there are so many applications are there for the magnetic effects. We can use in the electric bells. We can use the fire alarms. We can use in the crane for lifting the heavy loads. Right. Many more applications are there for the chemical effects. So tester, you know, tester is nothing but electric pen. When you keep the tester into current, you get the bulb to glow. Okay, LED, you know, light emitting diodes. Light emitting diodes are LEDs. Even LEDs also works on the electric effect only. Right? We can use LEDs in the tester instead of bulb because LED glows even brighter, even length in the LED. Okay. Even weak electric current flow through it. LED is the observation of light emitting diode. There are two leads of the length of LED. The longer lead is connected to positive terminal end and the smaller one is negative end. Like that by connecting, you can connect the LEDs also in the tester instead of bulbs, the latest development. So that is comes under magnetic effect of electric current, which is also used in the, already we have seen the video, they are used in the electric bells. In electric bell, they use the magnet. As long as current passes through the coil, bell will ring. When you stop the current, the bell also sound also disappears. That is temporary magnetic field. It's not permanent. That's why they are called electromagnets. So electromagnets are nothing but which are behaves like a magnet in electric presence of electric current. So again, next class we'll discuss a very interesting effect, heating effects of electric current. So many applications in our day-to-day life, starting from electric bulb, iron box, heater, geyser, wherever heat is produced by electric current is called heating effects. So in next class we'll discuss deep into that, and also there is one law called Joule's law, and then finally we'll conclude with the electric power and how to consumption of electric power, right? So we'll continue in the next class the same, and we'll conclude the chapter in the next class so that you can appear for the exam on the 30th December, test number 6. So test number 6 syllabus is entire electric current for you, right? Entire electric current comes under the, that is, there are 3 synopses are there. So 3 synopses, right? You have to go through everything and you have to work on worksheets also. If time permits, I'll solve some worksheet also in the class, right? So thank you very much, students. Have a wonderful day. Thank you.